Hi everyone, and welcome to this video. I am Karan Mashru, and today we are going to discuss the solutions of the problems of Weekly Coding Contest 127. And first of all, please let me know if I am properly audible. Okay, great. So let me share my screen and let us wait for some more seconds and then we'll begin. Okay. Hello. Hi Anushka. Hi Mohit. Hi Mohit. Yeah, so does anyone face issues in compiler today? I'm not sure, but I think in the first question, while checking for compile and run, small issue was coming. But while you click on submit, there was no issue. Okay, everyone, please like the stream if you like these solutions and like these streams. Thank you. Okay, so we'll begin with the first questions, and it was quite easy. So by the time we finish that, more people will join, right? So the first question is strong students in school. Okay, so let me brief you about this question. Sir, in first question there is compiler issue. Yeah, while doing compiler and run, a small issue was coming, but when you click on submit, there was no issue. Last problem first, please. We'll complete the first two questions very quickly. They are quite easy. Third one is medium. We'll go through that also, and then we'll cover the last question also. Just a small amount of time. So the first question, what it basically says is, in the first question, there are n students in a class, and the strength of each student is given. Okay. Now we need to make two groups of students or two sets of students in which there are m students each. Okay. Now one student can be in both the groups. Okay, there is no harm in that, and we want to form these groups in such a way that the difference of the summation of strengths, let me take someone for the summation of strength of these m students minus summation to the sum of strength of these m students. This difference is as maximum as possible, and I want to return this maximum difference. So what I can do basically, see, I want this difference to be as maximum as possible. So I want that one set of m students, their summation of strength is as max as possible, and for other set of m students, their sum of strength is as minimum as possible. So this value is as max as possible and this value is as min as possible, so their difference will be as max as possible. For example, if my n is equals to 5 and the student strength are 1, 2, 3, 4, 5, and if my m is 3, let's say, so what I'll do, I'll take these three students in one set and these three students in another set. So the sum of strength of these three students is 12 and the sum of strength of these three students is 6, and their difference will be 6. So this will be my answer. So if we go to the question, so that is what it is saying. In a particular school, the students are admitted on the basis of their strength. The strength of n students is given to you in the form of an array. The PT teacher wants to analyze two sets of m students. Help him find the maximum possible difference between the sum of strength of students in the two groups. Note, one student can be a part of more than one group. So basically, we want to form two m size groups of the n students. One student can be in multiple groups such that the sum of strengths and their difference in both the groups is as maximum as possible. So as I said, in one group we will take the m strongest people and in another group we will take the m weakest people. So the sum of strengths is as max as possible. Okay. So if we look at the code, so first of all, I have sorted the array. Then in my answer, I have added the strength of the strongest m people. So for I equals to n minus 1 up till I equals to n minus m, answer equals to answer plus array of I. and I have subtracted the strengths of the weakest m people because they will be in another set, so that will give me the difference. So for I equals to 0 to m minus 1, answer equals to answer minus array of I, and finally I'll return the answer. Yeah, I understand that if compile and run itself gives the error, it some like we will hesitate to submit the solutions because uh, there might be a chance of getting wrong answer and the points deducted, right? But like we'll make sure that it does not repeat again. But yeah, it happened this time, right? Okay, so now let's move on to the next question. Isomorphic strings. So basically, in the second question, we are given two strings, string 1 and string 2, and we are asked whether they are isomorphic or not. Okay, so now what is an isomorphic string? Isomorphic string is if you can map one character to another character from string s1 to s2 such that the same mapping occurs at all the positions, then you can say that it is a isomorphic string. For example, the first string is a b c a c f, okay, and the second string is x x y z x z p. So here I can say a is mapped with x because wherever there is a there is x, b is mapped with y because wherever there is b there is y, c is mapped with z because wherever there is c there is z, and f is mapped with p, and this is true for all the occurrences. So these two strings are isomorphic. Now instead of this, let's say it was a b c a c f and x x y z q z p. So these two are not isomorphic strings. Why? Because a is mapped to x in the first two positions and here a has q in its place. Okay, so this is not isomorphic. The same mapping should occur. Also, one character can be mapped to one character only. So for example, a c a, here if I have x x x x, then this is not isomorphic. Why? Because a is mapped with x, so x is already used. Now you cannot use x for c also, so this should also not occur. So what we can do is we can traverse both the strings. First of all, check the length. If their lengths are not equal, they cannot be isomorphic. We will return false. If the lengths are equal, for each character we will see if it has occurred before. If it has occurred before, we will store its mapping. For example, when we pass through ax, we will map a with x. Okay, so whenever next time a comes, we will check whether the respective character in the second string is x or not. Okay, if it is x, well and good. If it is not x, we will return false from there only. Okay, first thing. Second thing, whenever we are mapping a new character which has occurred for the first time, for example c here, so I see that I have to map c with x, but x is already used, so in this case also we will return false. Okay, so basically we'll move from left to right and see whether the character in string 1 is occurred before or not. If it has occurred before, we would have mapped it with some other character, so the same character must have occurred at this position also, otherwise we will return false. And if it is not occurred before, we will map it with the respective character in the string 2, and also we will check the condition that this character was not used before to map. Okay, also one important thing, if a is if with respect to a we have x, if with respect to a we have x in the second string and here with respect to x we have p, this is also isomorphic. Okay, it does not mean that if a is mapped with x, x should be mapped with a. That is not true. So this is also isomorphic, right? Now let's look at its implementation. So first of all, I have taken two arrays of size 26. One is map and one is used. Why am I using map? Map is used to map a particular character which occurs for the first time with a particular character. Okay. What is used? Used of I will be made one or one whenever that character is used for mapping. Okay, so for example, if I have AXCP, so when I map A with X, I will say used of X is equals to 1. So X is already used, now it cannot be used to map another character. Okay, so that if X, let's say, occurs again here, so we can say this is not isomorphic. Okay, so for that we are using used. Okay, so yeah, first of all, I marked all of them as -1, and length of first string is n and length of second string is m. If n is not equal to m, return false. Otherwise, move from I equals to 0 to n. If map of s of I s1 of I minus 97 equals to -1, it means if this character has not occurred before, if we have not mapped it before, then we need to map it with what? S2 of I minus 97, because that is the respective character in string 2. So first of all, we will check if S2 of I minus 97 is used before or not. Okay, let me zoom in a bit. So if S2 used of S2 of I minus 97 equals to -1, it means it is not used before. Then we will map S of I minus 97 equals to S2 of I minus 97. Okay, that why do we do minus 97? To convert the ASCII value into the respective numeric value. And we will say that used of S2 of I minus 97 equals to 1. If used of S2 of I minus 97 is not -1, if it is used before, then we will return false. Okay, and if map of S1 of I minus 97 is not equal to -1, it means that that character has occurred before. Then we will check if map of S1 of I minus 97 is equals to S2 of I minus 97 or not. If it is not equal, then we will return false. So whenever we get a break condition, we will directly return false, and if that does not occur for all the n characters, at the end we will return true. Okay, so is the second question clear? Is the second question clear? Shall we move on to the third one? Okay, great. So let's move on to the third one, mean query. Okay, great. So what does this question say? So let me just explain the question first, and then we'll move on to the question line by line. Third question is mean query, right? Is this the name? Have I pronounced it properly? Mean query. Okay. So in this question, what it basically says is we have an array A which contains n elements. Okay. We are given an array queries in which we this is a 2D array in which queries are defined. Okay, let's say there are q number of queries. In each query there is L1, R1, L2 and R2, where L1, R1, L2, R2 represents a subarray of this array. Okay, for each query we have to make an answer and add it to our answer list. So what is the answer for ith query? Answer for ith query is A of L1 and A of L1 plus 1 and up to and A of R1. So doing AND operation between all the elements of from L1 to R1 and doing OR operation of this complete value with A of L2 and A of L2 plus 1 and up till and A of R2. Are you getting my point? So in each query, we will be given two subarrays whose starting and ending points are L1 R1 and L2 R2. Right? And what will be the answer for the ith query? First, we take AND operation between all the elements from L1 to R1, store it, let's say this is Y, and we take AND operation between all the elements from L2 to R2, let's say this is Z, and then we do an or operation between y and z, and that would be my answer for the ith query. So we, for each query, we will calculate the answer and add it to our answer list, and finally we will return the answer. Is the question clear? First let me know. Is the question clear? So let's go through the question line by line. You are given a positive integer array A of size n and q queries. Great. Given an 2D integer array queries of length q, where each query has four integers L1, R1, L2, R2. You have to calculate A of L1 and A of L1 plus 1 and A of L1 plus 2 up to and R1, and do OR operation of this complete value with A of L2 and A of L2 plus 1 and up to A of R2. So first of all, you take AND operation between all the values from L1 to R1. You take AND operation between all the values from L2 and R2, and then do an OR operation between these two. Okay. So your task is to return an integer array answer of length q, where answer of I represents the answer for the ith query. And denotes the bitwise AND operation, or denotes the bitwise OR operation. Okay. So this is the question. Now the brute force method would be what? For each query, you run a for loop from I equals to L1 to R1, take AND operation of all of the elements and store it in a variable, let's say x or x1. Then you do another for loop from L2 to R2 and do an AND operation of all the elements and store it in x2, and then add to the answer list x1 or x2. Okay, this is the brute force method. Now this will take a time complexity of q into n, because when you run a for loop from L1 to R1, you are basically doing big O of n operation. And if you do this for all q queries, it will be big O of q into n, and this will give you time limit exceeded. So you need to think of something more efficient. Now please understand, whenever you get a bit manipulation question and you need to reduce the time complexity, whenever you get bit manipulation question and you want to reduce the time complexity, okay, whenever you want to reduce the time complexity, think bit by bit. Okay, please remember this. What you need to do, you need to think of calculating the answer bit by bit. Okay, so now how I will think. Here it is said that the value of AI can go at max up till 10 ki power 9. Okay, it is given in the question, and it is at least 1 because A of I are positive integers. If you convert it into binary, it will be less than 2 ki power 31. Okay. Okay. So I can represent all A of I values using 31 bits. Okay, from 0, 1, 2 up to 30th bit, where the value of 0th bit is 2 ki power 0, value of 1th bit is 2 ki power 1, this is 2 ki power 2 up till 2 ki power 30. Now how will I think bit by bit? So what I am thinking is, my answer to the ith query will also be a number which I can represent in 32 bits, right? So I am thinking, so basically my answer to ith query will also be represented using 32 bits. Now for each bit, I will think whether it will be 1 or 0. So I have got my answer. For example, if I can represent my answer to the ith query as a 4-bit number, so it is this, and this. Now each bit can be either 1 or 0. So I have to decide whether the ith bit is 1 or 0. Suppose this bit is 1, depending upon the conditions, this bit is 0, this bit is 1, and this bit is 1. So what would be my answer? My answer would be 13. Are you getting my point? So now for all the 32 bits in the ith query, I need to think whether the ith bit will be 1 or 0. That will give me my answer. Okay. Now if we think about the ith bit, when it will be 1 and when it will be 0. So let us again recall the expression, okay, for the ith query. What was the expression for the ith query? A of L1 and A of L2 and A of L3 up till and sorry, not L2, L1 plus 1, L1 plus 2, and A of let me write it again. What was the expression to the ith query? It is answer equals to A of L1 and A of L1 plus 1 and A of L1 plus 2 and A of R1 or A of L2 and A of L2 plus 1 and A of L2 plus 2 up till and A of R2. Are you getting my point? Now, if my ith bit is 1, okay, let me call this complete expression as x1 and let me call this complete expression as x2. If my ith bit is 1, then x1 or x2 will give me ith bit as 1. So it means that ith bit is either set in x1 or it is set in x2 or it is set in both x1 and x2. Are you getting my point? And if my ith bit is 0, so x1 or x2 gives me ith bit 0. It means that the ith bit is 0 in both x1 and x2, because whenever we take OR operation and if the result is 0, then that bit will be 0 in both of them. Okay. Okay, so now let us think about this, that the ith bit is 1, then it will be 1 in either x1 or x2 or in both x1 and x2. Okay, so now what is my expression for x1? It is A of L1 and A of L2. Sorry, again, this is A of L1 plus 1 up till and A of R1. So if my ith bit is set in x1, it is 1. Now here there is AND operation between all the elements. So if the ith bit is 1 in x1, it means ith bit is 1 in all the elements from L1 to R1. If ith bit is set in all the elements from L1 to R1, then only it can be set in x1, because from L1 to R1 we are doing AND operation. So if it is set in all of them, then only it can be set in x1. Are you getting my point? Similarly, ith bit will be set in x2 if it is set in all the elements from L2 to R2. So to conclude, if my ith bit is set in all elements from L1 to R1 inclusive or in all elements from L2 to R2 inclusive, then it will be set in my answer. Because if it is set in all the elements from L1 to R1, it will be set in x1. If it is set in all the elements from L2 to R2, it will be set in x2. And if it is set in either of them by doing OR operation, it will be set in my answer. Is this much clear? Okay, so now what we need to do is, for every query we will run a loop from I equal to 0 to 30, and we need to check whether ith bit is set in all the elements from L1 to R1 and L2 to R2 in an efficient manner. So how can we do that? So what we will do is, we will take a prefix sum. Okay, we will take a prefix sum. Okay, so let's say I take B of n plus 1 and 30 array. Okay, so in this, B of ij will denote the count of set bits j, the count of elements in which set jth bit is set from index 0 to I. Okay, when we do prefix sum, prefix of I tells us what? The sum of all the elements from 0 to I. Okay, if we take prefix sum, here I will take a 2D array, because what I want for each bit, I want to check how many times it is set up till index I. So B of ij will denote the count of numbers in which jth bit is set from index 0 to index I. Okay. Now, so if I want to check how many times ith bit is set from L1 to R1, how can I get it? I can say C1 equals to B of R1 I minus B of L1 minus 1 I. Are you getting my point? So what it basically means is I want from L1 to R1. Okay. B of R1 I gives me the count of numbers in which ith bit is set from 0 to R1. So this is 0 to R1. And B of L1 minus 1I gives me the count of numbers in which ith bit is set from 0 to I minus 1. So from 0 to I minus 1. So if I subtract this part from this part, I will be remaining with this part. Okay, that will give me the count of numbers in which ith bit is set from L1 to R1. Now, if ith bit is set in all the numbers from L1 to R1, my count should be equal to how much? R1 minus L1 plus 1. That is the number of elements from L1 to R1. So, if C1 equals to R1 minus L1 plus 1, or C2 equals to R2 minus L2 plus 1, then I will add to my answer 2 key power I, because ith bit is set in all the numbers from L1 to R1 or from L2 to R2. Otherwise, I will not add it to my answer. If it is 0 in my answer, I need not do anything. If it is 1 in my answer, I need to add 2 key power I. Okay. So this is the concept. Now let's look at the implementation part. I think there is some issue. Oh, I am logged out. Okay. So just a second. I'll just log in and then write back. I think segmentary would be easy in third question. No, how? Prefix sum is very easy to implement. Segmentary will take a lot of code, right? And in segmentary, it will take n log n time in while building, and then each query will run in log n time. Here in prefix sum, it will be built in big O of n time, and each query will run in constant time, and it is quite easy to visualize and run. Okay, so if we look at the implementation, so what I have done is, let me make it full screen. So I have taken one I have taken one vector answer in which I will be storing the answer. Then I have taken one 2D array b of n31 and then some variables. First of all, I have marked all b of ji as 0. Then for I equals to 0 to n, for j equals to 0 to 30. Okay, so j is basically the bit number from 0 to 30, and j1 is the value of that bit. So j1 is 2 key power j. Okay, so every time I'll do j plus plus, that the bit number will go from 0 1 2 3 up to 30, and j1 will be multiplied by 2. So value of the ith bit will get multiplied when it will go to I plus 1. First it will be 1, then 2, then 4, then 8, then 16, and so on. Okay, so for all the elements I will check if the jth bit whose value is j1. Okay, so I'll do AND operation with a of I. So if jth bit whose value is j1 is set in a of I, it will return j1. Okay, j1 and a of I will return j1. If it is not set in a of I, it will return 0. So if j1 and a of I is greater than 0, it means jth bit is set in I number. I will mark b of ij, that is ith number, and jth bit as 1. Okay, I am not taking prefix sum right now. I am just marking the bits who are set. Okay, then from I equals to 1 to n and j equals to 0 to 30, I say b of ij plus is equals to b of I minus 1j. So basically now I am doing prefix sum. So b of ij will represent the number of numbers from 0 index to ith index in which jth bit is set. Okay. Now I'll run the queries from I equals to 0. I have taken sum equals to 0. Sum is basically the answer to the ith query. But why I have not taken it as answer? Because I have taken answer variable here as vector. Okay. So L1 equals to queries of I0, R1 equals to queries of I1, L2 equal to queries of I2, and R2 equal to queries of I3. So I got the values of L1, R1, L2, R2. First of all, I have reduced the values of L1, R1 by 1 because in the question it is given 1 based index whereas we implemented the arrays based on 0 index. Okay. Now for all the bits from 0 to 30, I need to check whether that bit is set or not. Okay, for the ith query. So for j equals to 0, j is less than equal to 30, j plus plus. So j is the bit number and the value of that bit is j1. Okay, so j1 equals to 1 in the initial part, and j1 is multiplied by 2 every step. Okay, so first of all, in C1, I will store in how many numbers my jth bit is set from L1 to R1. So how I will get it? B of R1J minus B of L1 minus 1J. So C1 equals to B of R1J. And if L1 is greater than 0, then C1 equals to C1 minus B of L1 minus 1J. So in C1, I will get the number of numbers in which jth bit is set from L1 to R1. Similarly for C2. Now, if C1 is equals to R1 minus L1 plus 1, which means the number of numbers in which ith bit is set from L1 to R1 is equals to the number of numbers from between L1 and R1, then that bit will be set after doing AND operation. So if C1 equals to R1 minus L1 plus 1, or C2 equals to R2 minus L2 plus 1, then jth bit will be set in my answer, and the value of jth bit is J1 or 2 ki power j. So I say sum equals to sum plus j1. Okay, and after coming out of the loop, I'll add in my answer vector the value of sum, and finally I'll return answer. Okay, so let me submit it. Okay, I'll share the code for second and third problem. Please let me know if there is doubt in this third question, and please repeat the ith part. So can you specify, like, okay, I'll repeat a little bit of that. Okay, so why are we choosing the ith bit? Okay, and let me first share the code of the second and third question. Okay, code for third question. Okay, so I shared the code for third question, and now let me go to the second question. Code for second question. Okay, first let me explain a little bit about the ith part. Okay, so first of all, other people, please let me know whether this was clear or if there was any doubt. Okay, so basically, see, what we are said is in the ith query we will be given L1, R1, L2 and R2. Okay, and we are given an array A in which there are n elements. Okay, so in the ith query my answer will be A of L1 and A of L1 plus 1 and A of L1 plus 2 and up till and A of R1. So this value, or A of L2 and A of L2 plus 1 and A of L2 plus 2 and up till A of R2. Okay, so this ORed with this. So the brute force method would be to use a loop from L1 to R1, take the AND between all of the elements, store it in a variable x1, make a for loop from L2 to R2, do AND operation between all the elements, store it in variable x2, and return x1 or x2. Okay, this would be the brute force method. but for each query you will have to run a for loop of size n, and this will be your time complexity, which will give you time limit exceeded. So you need to think of something more efficient. So whenever in you get a bit manipulation question and you want to optimize it, you want to reduce the time complexity, most of the time, 95% of the time, think about bit by bit. Okay, so now understand here, the value of a of I is between 1 and 10 ki power 9, which means the value of a of I will be less than 2 ki power 31. So I can represent all the a values with the help of 31 bits. Okay, so when I will do the operation, that is AND operation from L1 to R1 and AND operation from L2 to R2, and doing OR operation between both of them, that my answer to the ith query will also be 31 bits. Are you getting my point? So what I will do is, now I for the ith query, so let's say this is my answer which contains 32 bits. So for each bit from 0 to 30, I will think whether it should be 1 or 0 into my answer. So I will think from bit to bit. Okay, I will think about bit to bit, whether my ith bit will be set or not set into my answer depending upon the condition. And that's where prefix sum came into the picture. Is it clear now? Shall we move on to fourth question? Please, people, write in the comments whether the third question was clear or not. Then we'll move on to the next question, last question. Okay, great. Some more people? One or two more at least, please. Hello. Great. Let's move on to the last question. So this is the last question, minimum price. Okay. So let me tell you the question first. Okay. So what is given in the question is, we are given n items. Okay. And we want to purchase all the n items. Okay. Now there is a price associated with each item. Okay, so the price of the ith item is p of I. We are given an p array which basically tells the price of the ith item. The additional thing here is that if you purchase the ith item, you can get f of I number of free items without paying them. So for example, the f of I value is 3, okay, and p of I value is 10. Okay, so if you purchase the ith item by giving 10 rupees or 10 units of cost, then f of I is 3. So you can pick 3 other items absolutely free. You will not have to pay for it. Okay. Also, the items which you picked for free. Okay. Let's say you had items with cost 5555. Okay, and you can get one free item with this item, you can get two free items with this item, you can get zero free items with this item, and you get three free items with this item. Okay, suppose you decided to purchase this item, so your cost is 5, and with this you get two more items free. Suppose you decide to take this and this item as free. Okay, now you cannot use this one and these three to purchase four more free items. Are you getting my point? You can only take f of I number of free items if you have paid for the ith item. If the ith item has come to you free because of some other item, you cannot use f of I value to purchase more free items. Okay, that's the condition. So basically, you are given n items. The ith item has price p of I, and f of I are the free number of items which you can purchase if you purchase the ith item by paying p of I. So you need to tell the minimum cost to purchase all items. Okay, the minimum cost to purchase all items, that is what you need to tell of. Okay, now what can be the brute force approach? The brute force approach, okay, first let us know if the question is clear or not. Okay, and let us also go through it line by line once. Geek is shopping at a grocery store. He needs to buy n items in all. The price of each item is represented by array P, where P of I is the price of the ith item. The shop also offers bonus on all items. If he buys the ith item, he can get any f of I items free of cost. Your task is to return the minimum amount of money Geek will need to buy n items. Note that Geek won't get f of I free items if the ith item has been received free of cost and not bought. That is what I made clear. Okay, so I think the question is clear. Please let me know in the comments. So let's move on to the solution. So what can be the brute force solution? See, the brute force solution can be pick or not pick. Okay, for ith item, we can either purchase it or not purchase it. At the end, we need all the items, but for which item we pay or not pay, that we can decide. Okay, so for each item, we have two choices: either to pay for it or not to pay for it. Okay, so we can. Okay, thank you. Test case again, please. Okay, see, I can give you test case, but here it will be a bit lengthy. Let us look at this test case. Okay, n equals to 4. The price of 4 items is 10, 25, 3, and the free number of items with first item is 2, with second item is 0, with third item is 1, and with fourth item is 1. And the minimum cost to purchase all the items is 8. How? I will purchase the last two items whose cost is 5 and 3 respectively. So my total cost will be 8. Now with the third item, I can get one free item, and with the fourth item, I can get one free item. Okay. So if I purchase third and fourth item, I can get two free items. So the first and second item, I can bring it for free. Okay. So I do not need to pay 10 and 20 rupees or units for the first and second item respectively. So overall, I will pay 8 rupees and bring all the four items. The minimum cost is 8. So that is the first example. Okay. So now the brute force approach to this question will be basically recursion, and for all the elements we will decide whether to purchase it or not to purchase it. Okay. But as you may be thinking of, let's say I call a recursion n and n. Okay. So let's say what does this mean? N number of items are remaining to purchase, and at present I am deciding whether to pay for nth item or not. Okay. So I will decide on nth item. Suppose I do not pay for nth item. So I will have to decide on the first n minus 1 items, and I will have to purchase n items. Suppose I decide to pay for the nth item. So now I have to decide on the first n minus 1 items whether to pay for it or not to pay for it. The remaining items will be how much? The remaining items will be n minus 1 minus f of n. Are you getting my point? Because if I decided to purchase the nth item, I will purchase the nth item. Okay, so that will be minus 1, and I can get f of n items for free. So the remaining number of items for which I will have to pay will be n minus 1 minus f of n, right? Plus p of n. Because see, this is the recursion function which I call. Okay, so I decide whether to what is the second element denoting? The number of items remaining to purchase. What is the first element denoting? Whether to purchase the nth ith item or not. So suppose I decide not to purchase the ith item, so remaining n minus 1 items, I will have to decide whether to purchase them or not to purchase them, and I will still have to buy n items because I did not bought anything. Suppose I decided to purchase the nth item, so I will have to pay price p of n, and what will be the remaining amount? Remaining n minus 1 elements from the first n minus 1 elements, I will have to purchase more n minus 1 minus f of n elements. Why? Because if I purchase the nth element, the remaining would be n minus 1. But if I purchase the nth element, f of n elements, I will get it as free. So minus f of n. Okay, so this much would be remaining. So in this way, I can call recursion. Okay, but this will definitely give us time limit exceeded. It will go into exponential. Okay, and here we will get overlapping subproblems property. So we can think of something more efficient, like we can think of using dynamic programming, right? So what I can do is, see here there are two things. Okay, so I can make a DP table where DP of ij will denote the minimum cost to purchase j items by, or to buy, I would say minimum cost to get j items. Okay, because we are not paying for all the j items. Minimum cost to get j items by making purchase, or by making optimal purchase, by making optimal purchase from first I elements. Okay, what does dp of ij denote? Minimum cost to get j items by making optimal purchase from the first I elements. Okay, so in this way we can call recursion, and whenever a states get repeated we will store its value. Okay, so that we do not calculate the overlapping sub problems again and again. Okay, so what can be my recursion function? Let's say I call with the jth item, I will say whether to buy it or not. This n would be the remaining amount of elements which I need to purchase. Okay, total I have, let's say, n amount of elements. Okay, and I will pass the price array, and I will pass the frequency array, and I will pass the dp array. Okay, now first of all we will write the base case. What will be the base case? So let this will be the function call which I will do from the main function. Okay, but this will be my I, this will be my remainder, how many elements are remaining to get, this is the total number of items which I need to purchase, this is price, this is free items, and this is dp array. First of all, if remainder is less than equal to 0, return 0. Why? Because what does remainder less than equal to 0 means? See, why I have written it less than 0? Because suppose the remaining items to get are 4. Okay, and with the ith item we can get 7 items free. So when I will do remainder minus 1 minus f of I, while I will decide to buy the ith item, my remainder may go negative. Okay, but we want to purchase at max n items because there are n items. So if remainder is less than equal to 0, there is nothing to purchase. So the cost of purchasing nothing is how much? 0. So I will return 0. Okay, now if I is equals to 0, it means I am currently at 0th item. Now there is no 0th item. I started with nth item, then I decided on n minus 1th item, then I decided on n minus 2th item, and I came up to first item. If I is equals to 0, it means we have decided upon all the elements, all the n elements. If I equals to 0, it means we were not able to get all the n items, right? Because if we were able to get all the n items, our remainder would be less than equal to 0. But remainder is greater than 0, then only I will come at this line. Now if I equals to 0, it means there are no more elements left to purchase. I will return, let's say, 10 ki power 13. Okay, basically I want to return infinite. So basically I want to denote that now it is impossible to go on this path. How? Let's say I have 3 items and I want to purchase 3 items. So in recursion, let's say I decided not to purchase the third item. Let's say I decided not to purchase the second item. Let's say I decided not to purchase the first item. So my remainder is 3, but there are no elements left. So basically I want to return infinite here, because my answer for this will be what? Minimum of this and this, minimum of this and this. My answer to this will be minimum of this and this. So this is not possible at all. So basically I want to return infinite cost from there, but since infinite is not possible, we will return 10 ki power 13. Okay, now so these are the base cases. Now if dp of I remaining is not equal to -1. If it is not equal to -1, it means that state has already occurred before and we have calculated it, so no need to recalculate it. So I will return dp of I remainder. That is, what is the minimum cost to purchase to get remainder number of items by purchasing the optimal number of items from the first I items. Okay, but if that is equal to -1, it means that is not calculated before, then I need to calculate it. So how will I calculate dp of I remainder? So dp of I remainder is nothing but minimum of what is the recursion function. So now I will either purchase the ith item or I will not purchase the ith item. Okay. So it will be minimum of both those cases. So if I decide not to purchase the ith item, then my index will become I minus 1. The remaining number of items will remain remainder only. My total number of items will remain n only. My p and f will remain as it is, and I will return the dp array. Comma, suppose I decided to purchase the ith item, then my function will become I minus 1 remainder minus 1 minus f of I, right? Because if I purchase the ith item, that is minus 1, and f of I are the number of free items which I get with it. Okay. When we write the actual code, this will not be f of I, it will be f of I minus 1, because in dp table I am taking dp table as one based index, but our price and f array are zero based index. Okay. We will look at the code, you will be clear at that time. So this remaining items will become remaining minus 1 minus f of I. N will remain as it is, p will remain as it is, f will remain as it is, dp will remain as it is. But if I decide to purchase the ith item, then its price will be included, so plus p of I. So dp of I remainder will be minimum if I decide not to purchase that, or if I decide to purchase it. So minimum of both of them. So this is my dynamic programming code, and this will work. Okay, this is the memoization code. Okay, now let's look at its actual implementation. So let's look at the actual implementation. So what I've done is I've taken one dp table of n plus 1 and 1000 plus 1 size, and first of all I've marked all as minus 1. Okay. Also I have marked for I equals to 0 to n dp of I 0 as 0. Why? Because see, dp of ij tells me the minimum cost to purchase j items by purchasing the optimal among the first I items. If j equals to 0, it means I do not need to purchase any item, then dp of ij will always be 0. Because irrespective of how many elements you have, let's say you have I elements, but you want to purchase 0 elements, so your cost will be 0. So dp of I0 equals to 0 for all the elements. And then I have finally written function n and n P, F, and DP. So what does this denote? So I denotes the current index at which I am looking at, whether to purchase it or not to purchase it. Remainder denotes the remaining number of elements which I need to get. Okay, not to purchase, which I need to get. N denotes the total number of items, pre is the price vector, F is the free vector, and DP is the DP table. If remainder is less than equal to 0, I do not need to purchase anything, I will directly return 0. If I equals to 0, it means remainder is greater than 0. That's why we came at line 37. And if that's why we came at line 39. But if I equals to 0, I'll return a very big value that now it's not possible to purchase on this path by this combination. Now, if dp of I remainder is minus 1, it means that state has not occurred before. Then dp of I remainder is minimum of I decide not to purchase the ith item. So function I minus 1 remainder n, p, f, and dp. Or function I decide to purchase the ith item. So it will become I minus 1 remainder minus 1 minus f of I minus 1. Why? Because f array is 0 based index. N, P, F, and DP plus P of I minus 1. That is the price of the ith item. And then I will return dp of I and remainder. Okay. So what will be the time complexity here? N into remainder, or n into 1000, because that is the dp table which we are filling. Okay. And finally, we will return whatever value will be returned by this recursive function. So is everything clear? Please let me know. I think in the recursive function, there is no need of the third parameter n. While coding, I don't exactly remember why I took it, but I by looking at the code right now, I think we are not requiring it. Is everything clear? Please let me know. Okay, great. Other people, please let me know. And everyone, if you have understood, please like this stream. Also, if you have understood the solution and if you have liked this solution, you may take a screenshot of the screen and share it on LinkedIn, tagging me, Geeks for Geeks, and Sandeep Jain sir about this if you have enjoyed it. And if you have any doubts, please let me know. Otherwise, we may end the stream here. Other people, please let me know, one or two more, whether this DP problem was clear or not. At least one more person. Okay, so if you have any doubts, you may let me know. Otherwise, we'll end the stream here. Let's wait for 1 minute more. If there are no doubts, then we'll end the stream here. Okay. Let me share the code for the fourth question. Okay, great. I think we can end the stream here. Thank you guys for joining. I hope you have enjoyed it and you have understood all the solutions of all the four questions. And I wish you a good night and thank you for joining.